Hello guys, so the thing I wanna talk today about is something that kills most systematic research before it even begins. And it's not overfitting, it's not p-hacking, and it's not of the things that people usually blame. It's the model class was wrong from the beginning, like you can do everything else right and still produce completely useless backtest because the model you fit has nothing to do with how the data actually behaves. The core idea is here at the top. A model isn't something that you put on top of the strategy after the fact. It's the thing that says what kind of prediction is even coherent given what you're looking at. So before you do anything, before you write any signal logic, you need to answer, what am I actually forecasting? Next return, a future price level, or a spread residual, well, maybe volatility, regime probability, because those are structurally different problems and they need different model families. Like take a linear trend model versus ornstein-uhlenbeck process. A trend model is assuming persistent drift. OU process has this restoring force. The drift term is k theta minus x of t. So the further you're from the long run mean, the stronger the pull back is. So those two models are not interchangeable. They're answering completely different questions. And if you pick the wrong one, your backtest is measuring the mismatch, which is bad. But a misspecified model that happens to backtest well is actually worse because now you have a false confidence. So the first thing to figure out is just what kind of process it is, and this is more structural than people treat it. Mean reversion series is stationary AR1 coefficient below 1. The drift is negative and the level is high and positive when it's low. That's the mechanism. That's what you're testing for. ADF, KPSS, half-life, negative long horizon, autocorrelation. And the thing is, these tests aren't just boxes to check. They're telling you whether the model family you're about to use is even asking the right question. Also, if you're worried about the amount of buzzwords were said, I also pull up the research source below each section. So let's watch at the VIX example. I will actually show how wrong model choice affects real results. So this is actual VIX chart after 2020 spike, and as you can see on the left we have linear model and on the right we have mean reverting Ornstein-Uhlenbeck process. And let's reveal the data. So as you can see, when the spike happened, our linear regression was simply suggesting that VIX will keep going up. As you can see, 60-year expectation shows that VIX in 60 years will be around 16,291, which is obviously not going to happen, while our mean reversion process suggests realistic forecast of 19.7. So as you can see, as I reveal it, initially it doesn't look that great, but overall long-term forecast remains much more accurate than the linear regression suggests. And the model choice is not just trend or mean reversion. You need mean model and variance model and observation model, decision model. Most people think that the mean model and just forget the rest. But if your variance model is wrong, your sizing is wrong. If your observation model is wrong, you're trading noise and you've misidentified the signal. You can read it yourself because there's too much information for one video. Now let's talk about regimes, parameters, and Kalman filters. Honestly, they're not completely related to the topic of today's discussion, but I wanna mention them in today's video. Two things break static models, regime changes and parameter drift. Kalman filter handles the second, regime switching handles the first. For Kalman, the key thing that you're tuning the Q over R ratio, process noise to observation noise. High QR ratio and the filter adapts fast but chases noise. Low QR ratio and it's stable but too slow to respond structural breaks. It may sound and look complex, but once I show you the visualization, it will become much clearer for you. So now let's see. Let's first of all keep it at default settings. And as you can see, as I reveal the price action, the Kalman filter trend actually adapts pretty quickly to the break, while rolling a linear regression can't adapt quick enough to capture the change in direction. Now let's make it very fast by noisy. I will move it slowly. As you can see, every tiny wiggle affects the forecast significantly. That's the problem. So it will adapt pretty quickly, but it will also capture the noise much faster than you actually want it to be. And for regimes, this makes it concrete. So here is our synthetic price path for regimes, trend range, downtrend. The regime switching strategy uses ornstein uhlenbeck mean reversion strategy in the range states and linear trend model in trend states. Linear only uses trend rules everywhere, including two regimes where that's structurally wrong. The PNL difference comes entirely from model selection. The signal logic inside each regime is simple. The regime filter is doing all the work. So as you can see, we have regime switching model. We will have PNL here compared to linear model only. As I reveal price action, you can see how regime switching model adapts to each regime and produces positive wealth for us. Now let's switch to linear model only. And as you can see, in range bound conditions, it struggles significantly and loses money for us. So here is a clean workflow for you. Once you got the model family, the next failure mode is parameterizing against PNL. Set your lookback windows, lag order, regime count, QR ratio, thresholds, all of it, before you look at strategy returns. Use forecast error, information criteria, parameter stability, and if you optimize those against PNL, you just reintroduce the decrease of freedom problem that model selection was supposed to constrain. The workflow is forecast target, state variable, diagnostics, model family, parameterization, and then signal search. Strategy search is step 6. Everything before is model selection. That's the point. So here are the sources for everything I provided in this video. And yeah, the question isn't what signal to test, it's what kind of process generated the returns you're trying to forecast and what model class is even coherent given that. Get that wrong and everything downstream is built on mis-specification. So all of the interactive stuff and guide is on my website. This video has been a bit more technical. This was the end of series 2 of quantitative trading with proof firms. I know the strategy development hasn't been shown yet, but you will see that in series 3 or 4. And until the next time, be safe.